So I'm going to go over it. So this is the question. Marty's 56, owns an investment worth 400,000. If the interest rate is 8%, estimate, that's key number one, right? That rule of 72 is probably going to happen here. The amount that he had in his account at the age of 20. Use the rule of 72, so it's kind of like a giveaway. So step number one, right, would be using this formula. So 72 divided by 8%, that gives you 9 years. Oh, thank you. So step number one is figure out this is a doubling time. So every 9 years, it will double. But here we're going backwards in time. I would still say it's probably good to have a table like that. You don't have to, but once we get to functions, you'll see why I like tables. So I will start with, we are what, 56, and we have 400,000, correct? So now we're going to go back in time. So you know how usually we started at 18 or when we were younger, and then we just added time, right, to go into the future? Now I'm going to do the exact opposite. So I'm going to go, what's going to happen to the money if I go back in time? I divide by 2, so I'm at 200,000, take away 9, right? What are we at there, 47? 47, okay? Then you got to keep going, divide it by 2, that's 100,000. That will take me back 9 years. So this is 38 years. So that at that point, Marty's 38, has 100,000. We got to keep going, right? Another half, you half it again, you're at 50,000. You got to take away a doubling time. That gets me to 29. We're almost there, right? I'm 29, so take away another 9 years, you get to 20. And what do you need to do on this side? You need to divide by 2 to get to 25,000. Okay, so that is the answer. Marty had 25,000 at the age of 20. And think about it, right? You do double every 9 years. We double our money every 9 years. And so you keep track of time, which is consistent. And on this side, it's either doubling or halving, right? You're halving it in this case because we're going back in time. So, yeah. Without the table? Yes. Do you have something in mind, or? What you could do is, let me see how else I've seen this done. Sometimes students just do this, okay? They just say, well, okay, I'm at 400,000, right? And then just keep on dividing it. They're like 200,000, 100,000, 50,000. They just keep going, and they keep track that every time this happens, I gotta take 9 away, right? 9 years go by. So they keep going. They kind of just do it this way. They don't necessarily do a table, but other than that, I can't think of another way of doing it. You don't have to do the table. Another thing that they could have asked you is like, how long does it take to go from 400 to, let's say, 25,000? They could have asked you that. Then you would have just gone and added up how many times do 9 years go by. Okay, so 4 times 9, that'd be 36 years. So unfortunately, I can tell you this, that most of the time you stop after 3. Like most of the time you don't go past it, but I want to prepare you for that. Okay, so this one, if you want to put a title to this, is like we go back in time, right? So if you copy this down on page 27, you can say going back in time. Like a little subheading, okay? And then you'll at least have seen a variation of the usage of Rule of 72. I don't want you to always think it's the same, it's the same, it's the same. Normally we go into the future. I've never seen going back, but I don't think, I wouldn't rule that out. Okay? All right, so that concludes the Rule of 72. You're gonna see it